Hello and good afternoon, everyone. Thank you for joining our free online lesson. For today's topic, we will take a look at the Inventor dynamic solution. Right? So my name is Nabil Fikir bin Shaizan, an application engineer from Acad Systems. Right. So inside of Inventor, there are also one simulations that allow you to simulate the moving parts. So for today's, we're going to take a look at some of these things. So the first thing is we're going to take a look at the joining parts, the movement area. Then we're going to take a look at some of the loads and all of the things that you can input, such as the rotation motions, so on. And then we're going to simulate the movement here. And then we're going to find the results, and most likely we're going to export that result into a stress analysis. So let me show you the Inventors. So right now, what I have here is the assembly files, right, of this cutting saw. So the assembly here, there are some few moving parts over here. For example, this rotation here, so this can be rotated, can be moved. This can also be moved. So we have a few things that can be moved here, and we want to simulate this as a dynamic simulations, and we're going to take a look at the result of this. So to go into the dynamic simulation environment, so you can go to the environment tab over here. Then you can go to the dynamic simulation. You press OK, and right off the bat, it turns into a dynamic simulation tab over here. And we have the dynamic simulation tree browser over here. So let's take a look at some of the things that I can do from here. I can click at one of the items over here, and then I can try to move it around. And then you will see we can try to move it. And we have some little bit spring loop. So this is just some simulations that indicates that this is the moving parts that can be done inside of dynamic simulations. And this can be rotated as well. Same goes with this one. Right. So all of the things that you find at the dynamic simulation is automatically converted. So if you take a look at the left side over here, so we have standard joint over here, which indicate that this is the joints that can be moved, right? So and then this joint is actually created from the assembly files where you use constraints. And the constraint that you have done before will be converted into a standard joint over here, which allow for movement that I showed you before. So currently we have three. One is for revolution, which is the rotation of these things. Now, if I click plus button, then you will see there are mates over here, and then there are mates over here. Right. So we have these two, and this type of rotation can be moved, rotate. Second one also, this one can be rotated, and then we have this line over here. Now let me just go back, and let's say I want to add one more moving item, which is this one. So I can click finish dynamic simulations, and currently I have this item which is bench. So if we have flush, we have mates, but currently it cannot be moved because it is set to grounded. So let me uncheck the grounded. So we have flush, we have mates, but this thing can move up and down over here. So if I want to fully constrain, either I select the grounded or I can constrain it from the top over here. But what we know here, this item can be moved really. Now if I go back, so let me just set back a little bit upwards. So if I go back to the dynamic simulation tabs, it's going to convert this into a moving part. So if I take a look over here, so we have 4 moving parts. So if I click this item, I can move it inside of dynamic simulations. This will become as part of dynamic simulation as well. And then I will click plus button over here, so we have flush mates, which is having consumed by this primitive. So this is the joints that has been done automatically. So if I want to turn off this auto joint, which has been converted from constraint, I can go to the simulation setting over here. I can uncheck this one, and I can press OK, then you'll see the joint is no longer here. So if I try to move, right, but this one can still be moved because it is part of the mobile group. But the standard joint is not, it's no longer being put over here. So instead of standard joint over here, so let me just turn back on. There are some other things that you can do from here, is that you can just right click, then you can go to the properties, and this is the moving settings that you can done over here. So maybe I want to rotate this motor over here. I can just control the value from. For this case, let's just take it. Other things that you can take a look over here is the mobile group. So this is where it will list down all of your moving items. So we have fans over here, we have cam, photo, and so on. So if I right click and go to the color mobile group, and it will highlight you the item that can be moved. So this one can be moved, this one can be moved. It's only show you the item that able to move from you. So you can see clearly which item is related to the dynamic solution. So let me just uncheck the moving parts of this. Right. So right over here we have this simulation play over here. So if I click play, so nothing will happen. The timeline will be moved over here, but nothing actually moving because we haven't put any loads into this item yet. So if I click play, then you can see the rest of these items become gray as well. So I cannot edit this item as well. So to move back to editing methods, so you can click at the construction button over here. Right, so you can click at the construction buttons, and it will allow you to put the settings into your moving item. So let's take a look at the insert joint over here. So we have the standard joints, which has been done automatically, which has been taken from the Inventor constraints. Then there are other joining tools that allow you to specify there are connection between this item and this item. So if I take a look at the insert joint over here, and this is where the joint must be done manually. And if I drop down, there are a few types of connection between one item to another items. So if I cannot understand what one of these items actually means, I can also click at this display joint table. So you kind of have roughly the image of what this joint actually do. So if I want to have a joint, something like a spring, I can click at the spring over here. If I want to have a rolling joints between two items, so I can click at the rolling joints, and then I can select what type of rolling joints that I want. So maybe cylinder or planes, maybe cylinder inside of cylinders, right? Or maybe I want sliding joints, or maybe standard type of joints. So this is where the standard type of joints that has been put automatically. So if you uncheck that, you can just do standard joint manually from. Right, so the first thing that I would like to do is that I would like to ensure that when this item rotates, this item will be followed as well. So for that case, I will use the cone on cone, right? So if you don't confirm, so you can just file from here, from the image over here. So I want to simulate this type of rotation. So one item rotates and the other items will be driven. Right, so when I click this item, so the rotation, the area that you need to click for this type of joint is that the first one, you need to specify the diameter, and the second connection that you need to specify the area inside over here, right? Or you can also refer to this image of what area that you need to click. Right, so the first one is the diameter, so that will be the diameter of here. So I will click at this item over here. Okay, let me just cancel this one and insert again. So the first one will be this as a diameter. The second one will be one of the face over here, which is this one. So when I click OK, the rolling join has been done. So you can see we have a rolling join. Okay. So when I click one item, I can move, and you can see the other item will be moving as well. So that is one of the items for movement. So let's say if I would like to have this move up and down. Now, before I show you the moving up and down, I will show you one example of force first. Now, if I would like to add a gravity, so this one will fall downwards. So for the gravity, you can find from the external loads. You can click external loads. There are gravity over here. So I can just right click and define the gravity. And I can select the entity, which is where the direction of gravity will be falling through. So that will be this direction downwards. If the direction is incorrect, you can just click the direction on. Right, so I can press OK. Now the gravity force has been applied. So let's try to do some simulation first. So we have this simulation player. If you accidentally close, you can click at the simulation player over here, and then I can click play over here. Then you will see that one has been dropped. Okay, so let me just undo. And if you play, it will drop. And some other items also affected by the gravity, which is this. If I click play, there are some slight moving parts over here. So what are the items that you can do from here? So one is that you can control how many seconds. So let's say I want the process will be around 0.5 seconds. Right. So for this case, I need to click at the construction first. So I want this to be 0.5 seconds. And this is where the how many picture it will capture, right? So I want this to be slightly slower, right? So the play button will be slower. So I can increase the image of capture. So let's say around 200 frames per second. So that will be 100 seconds. Right. So 100 seconds per 1 second. So when I hit play, so it will drop slightly slower. Right, so that is the simulation player. Right, so let's continue to add more type of force over here. Now, let's say if I want this to drop. So let me go back to the construction. So if I want this to drop, but I don't want to drop directly downwards, I can select, let's say I want to drop. If it touch these items, it will stop at these items. I can specify using insert join. Okay, right. So let's say I put insert join over here. So this one will be moving downwards. That will be the equivalent of z-axis downwards. So that will be something like a moving parts in 2D interface, right? Or 2D directions. So for that case, I can just use 2D context because the moving direction is quite simple, just straight downwards. And I want this to have a contact with this item over here. So I can select 2D contact, and select this face, for examples. And the second one, it will contact and stop if it touch this face. So when I hit OK, and I hit play, it will drop and it will stop if it touch this 2D profile. Right, so that is some of the examples for the joint. Okay, so for this type of joints that I would like to do is that I would like to have these joints between these two items. Okay, so I would like this item to stop once it has reached this cam item over here. So from here to here. Again, I'm using the insert joints, selecting the 2D context. So selecting the edge, so we have this edge. Second one, I can select this edge. Then that will be the equivalent of a 2D area. So when I hit OK, and I try to move it, and I touch, So you can see it is touching that item. It will stop. We have some occlusion over here. Right. So that is some of the occlusions that we have. We can also change the settings of our joints, right? So maybe the collisions. So you can find back the joints that you have. So under the contact joint over here, so that will be the second one. I can just right click to edit the joints. So if you notice before, we have bouncings while this touching this item over here. I can turn off the bouncing by setting the reposition into 0. Another thing that I would like to show is the display force. So let's say if I want my display force to be shown, I can put 1, for example, and I put K, and then when it touch, it will not have bouncings, and it will also show me the force. Right, so the force direction is quite large. We can see the red one, so that will be the force directions. Now let me just change back the directions. So let's say this one is 0.003, for example. I want the bouncing back to 0.8, and I can press OK. So we have the bouncing area. Another thing that I would like to put over here is the springs. So I would like to have a spring direction from here to here, because if I just hit play, this one will not be touching or at the right side, because there are no spring attached. So let me just add a springs. So the spring, you can go ahead at the insert joints. Then you can find a spring damper. So the connections, I will select from this edge over here, and the other edge will be either here or here also can. And I can press OK. The spring will be created. But if I just directly press play, nothing happens, because you need to add some of the settings for the spring, right? So some of the physical properties on the spring. So let me just go back. So to change the spring settings, so I can find the spring setting from here. I can find the force joint, spring damper. So I can just right click and edit the properties. So currently the stiffness is 0, so that is the reason why nothing happens. So I want the stiffness, let's say around 2.5 Newton. The free length, let's say around 42. And let's say this is a little bit on the appearance for your spring. So the spring will be under 5.2 radius, or maybe just 5 radius. Then the next thing is I can adjust how many turns that I want for the spring. So let's say around 10 turns. So you have 10 round turns, maybe 10 is a little bit too much. Let me reduce to 8. Okay. And you can also adjust the wire radius over here. Right. So for this case, let's say I want this to be 0.5. I can press OK. So you have this spring patterns with some loops. So let me just make it a little bit front. So when I hit play, so you can see there are stress applied, and then you can see there are force which indicate at the front over here. Right, so this is the force directions. I can hit undo and I hit play. You can see they are moving part because of this spring. Now there are no rotation yet, so we're going to add some rotation for this. So go back to constructions, and then for the rotations, that will be these items. So you can find under the mobile group over here. Okay. No, I believe that one you need to find under standard joint. Standard joints, that will be, which is the one. Okay, I believe the division number 3. So this one should be this one. So I can just right click and then go to the properties, and then I can go to the degree of freedom over here. So from here, you can apply a torque if you want to, or maybe apply the industrial conditions. But what I want to apply is the impulse motion. So there will be some motions for this, which is the rotation motions. And I want to enable the impulse motions. And I can set the velocity. I can hit the value over here. I can specify the starting points and the ending point speeds. But for this case, I don't want to have 2 points. I just want to have a constraint rotations. So for that case, I can select this button over here just to able to apply constant value. So the value, let's say around 10,000 degrees per second. And I can hit OK here. When I hit play, then you will see there are now some rotation here. Right, but the moving parts is not very accurate. So let me just edit back the insertion point over here. Oops. Okay, so I believe that will be under, is it rolling joint? Okay, so properties, or not, sorry, not properties. I can edit back the joints. So if I click over here, hit play, I can hit play again. So still incorrect. So let me just undo. Maybe I would like to delete this joint. So I have prepared the cone for the rotation. So let me just delete this joint. Oops. Okay, so the joint has been deleted. Every joint. So let me just undo. I only want to delete the rolling joint. Okay, so at these items, the diameter already being prepared. So let me just open the diameter instead. Oh, sorry. Right, so we have a surface over here. Make it in terms, and I try to add again the joint for the cone on cone. Should be this diameter. It not the outside, so there are some mistake that I made over here. So this diameter. And then the second one is the face over here. So like okay, so like try to rotate. So the rotation is correct already, right? Okay, so let me just disable the cone already because we already add. Okay, so when I hit play, so you can see the rotation is correct already. And it will rotate with this spindle as well. Okay. Okay, then we have now that we have the rotation of this item, now we want to see the result. So for that case, you can go to the result over here, then you can select output grapher. And this output grapher will show you what are the items that you can see for the result. You can click the output grapher, and then this output grapher will play when you play the simulation settings. So let me just open the simulation settings over here. And the dynamic simulations, let me just make it slightly larger so you can see. Okay, right. So there are no graph yet. So when I hit play, then you will see they are moving. So you can see they are moving item over here. Right. So the items that I would like to show, you can find from the plus button over here. Now this is the result that you can find. So the result that I want for this, let's say I would like to have a under division 2, I want to show the velocity, so I can find the velocity. It will show me the velocity over here. The velocity, since I apply constant, so that will be straight line, so there are no velocity area over here, so that will be constants. So the area that I would like to add, let's say the so you can find maybe force, for examples. You can see the force area that actually apply from here, the positions. Okay. So maybe I would like to add some other items as well. So under prismatics, maybe some force again. So we have different type of force, different area from here that you can find. Let me just change. Okay, the item that I want for some reason is not here. I don't mind. Okay, so let me just show you the moving parts. So when I hit back, so you can see when I hit play, so it will create this one. Right, but for this case, it's already been created. So that is the reason why you'll be able to see it. Right, maybe I want to see other information here. For example, prismatic one. This one is for frames. Maybe welded group over here. Maybe I want to see velocity, so I can just turn on velocity. And this is velocity that actually happened on the guided weld one, which is this item over here. Now you can see at the start of the item, the velocity is very high. So the reason why is because we have some impact before. So I can click at this item at the top over here. So you can see this is the time that actually happens. So you can just drop. Right. So if I go back from the top, so this is the starting points, and I go to the next, and then go to the next, and then you can see it is actually moving from here. I can also just drop over here and select, and it will show you under this time what moving part actually happens. So for this case, I would like to see at the highest one. So you can see the highest one is actually at the second one. The second one is where it's, sorry, the third one is where it touched, right? Because we have a moving part from here and then it bang. So it has some collision at the start. So that is the reason why the velocity is high. So we can also find the force over here and some of the settings that you can also find. Now let's say some of the things that you can that you find from here, you able to explore out the results. Now what I would like to do next is I would like to export the result of my item over here into a stress analysis. So I can done some stress. So if you go to the stress, you'll be able to apply some loads, you're able to apply some constraints, some materials. So sometimes they are a little bit tricky when you want to apply the loads. So for that case, you can use dynamic simulations to simulate the moving parts and simulate what load actually produced based on the moving part. Now to export into a analysis, you can go to the stress analysis area over here, then you can select export to FEA. Or you can also click from the output graph over here. You can select export to FEA, and then what type of part that you would like to export. For my case, I would like to export this button over here, and I click create, and then you can click OK over here. But I cannot click probably because I need to go back to construction area, and I hit this export to FEA again, and this is the item I would like to export. Then I can hit OK. I can select what are the items that I would like to export. Click OK. And then once you have a click at that particular items, here you can specify at which times that you would like to export out. So you can just click at the button over here, but for some reason it does not show me the button for me to click. Let me just slap again. Okay, let me just try it. For some reason, the button is gone already. So previously you have the button. Position, pause. Okay, probably that one I need to refresh back again. But once you have clicked, maybe you want this button over here, you can just click tick box, which is same. This one, I can click at this tick box over here. Once you have clicked at the button over here, you can just close your dynamic simulations. And then from here, you can just go to environments. Instead of dynamic simulation, you can just go to stress analysis. And you should be able to find it under motion notebooks. But since I cannot click at the which of the items that I want to export it out, so for that case I cannot. So part is missing. It should be able to allow for you to click, but probably a bug or some things. For some reason, it does not show me the checkbox for me. Right, so that is the that is the damage simulations that I would like to show you guys. So I believe that is all for today. So thank you everyone for joining, and I hope I can see you guys on our next freelance lessons. So thank you everyone and have a nice day. Bye.